calculate value of the current in 3 plus J2 ohm resistance or branch and verify the reciprocity theorem. Means our aim is the calculation of current in 3 plus J2 ohm. This impedance, this current, in this current we are interested. And then we want to verify the reciprocity theorem, means we have to shift the source here and we have to calculate current at this particular point and we have to verify both values. Is it right? So here in this case, use any method for the calculation of the current. Use any method for the calculation of the current. Is it right? Now what I will use, what I will do, in place of using the mesh analysis means this is loop 1, this is loop 2, then equations will be complicated because it is complex numbers calculation. Because we have to find out the delta 1 and then we are able to find out the I1 or I2 in that way. If we are using the nodal analysis, it will be the node 1, this will be the ground node. And in that case, again, 1 divided by something, 1 divided by something, 1 divided by something, because potential difference divided by impedance will be the current. In that case, again, the calculation part will increase. So that what I can plan, here I will reduce this network. I will find out its parallel combination, it will become one loop, I will calculate its current. Then I will use the current division rule here and I will plan for the calculation of current in this branch. Is it right? So use any method. Our aim is the calculation of the current. Here I am using the method which is reduction method. Yes, we are minimizing the network and then we are calculating the current. I will consider the case 1. That is case 1. In this case, what we can plan? In this case, we will reduce this network and we will calculate the current in 3 plus J2 ohm impedance. Case 1, I will write here, reducing above network, we get. We will reduce this network first and we will calculate the current. Is it right? This figure will be something like this. Its figure will be something like this because we are interested in the calculation of the current. Use any method. I am using the reduction method here. This is one branch, and what I will do, I will find out the parallel combination of that. Its parallel combination, I will write here. This value is 2 plus J3. This is 2 plus J3 ohm impedance as it is. And for case 1, I will call this parallel combination as ZP1. And I will find out its value. How will be its value? Z1 into Z2 divided by Z1 plus Z2 means it is minus J5 into 3 plus J2, this total divided by minus J5 plus 3 plus J2. Z1 into Z2 divided by Z1 plus Z2, I will find out its value. So in this case, I will use the calculator here and we will try to find out its value. I will use the calculator and I will shift the calculator in the complex mode. Now calculator is in the complex mode. I will find out the calculation of the numerator. In this particular case, if we are finding the calculation of the numerator, it will be something like this. It will be something like this. Start bracket. Already I have taken start bracket. This is minus J5, that is 5i, this close bracket into 3 plus J2, start bracket, 3 plus 2i. I will close the bracket, which is equal to, this is the real part of the numerator. The real part of the numerator is 10, then shift of is equal to, this is 15i, that is minus J15 is the numerator. How will be the denominator? Here I will use the similar calculation. This is minus 5i. I will close the bracket, then plus 3 plus J2. 3 plus 2i. I will close the bracket is equal to. The real part is a 3. Real part is a 3. Shift of is equal to. In this case, the imaginary part is again minus 3. This is minus J3 is the imaginary part. If I will find out this division, how will be the division? Start bracket 10 minus 15 I will close the bracket, divided by start bracket 3 minus 3 I will close the bracket is equal to, its real part is 4.16. This is 4.16 is the real part of this impedance. Then shift and is equal to, shift and this is equal to, it is minus J, this is minus J 0.83. This is 0.83. This is the ZP1, that is impedance. Now we know everything. Now I will find out the total current. In this case, for first case, I will call this total current as, for first case, I will call this total current as I1. Is it right? Now in this case, this I1 is equal to total voltage. That is 330 plus J0 is the total voltage, which is this, divided by total impedance, and total impedance is that is 2 plus J3, this value plus this is plus, then this value 4.16, this is 4.16 minus J, this is 0.83 is the total impedance, addition of these two impedances, which is equal to, first I will complete the denominator. First, I will complete the denominator in this case. How are the calculations? Start bracket. Here it is, start bracket 2 plus J3. It is 2 plus 3I. I will close the bracket plus start bracket. That is 4.16. This is 4.16. This is 4.16. This is 4.16 minus 0.83I. I will close the bracket is equal to, this is the real part. Real part is 6.16. This is 6.16 is the real part. Then shift and is equal to, it's 2.17. There is a plus J. 2.17 is the imaginary part. And this value is 30 plus J0 in the numerator. Then here I will find out this division, means we are able to calculate the current. If I am finding this division, again start bracket. 30 plus 0I, 30 plus 0I, this is 0I, otherwise no need to write that value, divided by start bracket 6.16 plus 2.17I. I will close the bracket. This division we are carrying out, which is equal to 4.33. This is 4.33 is the real part of this current, and this is minus J, this is minus J 1.52. 1.52, this is the current I1, which is in this total current, in this total case. Is it right? Now if we know the total current, then we are in a position to find out the value of the current in the required branch. I will start from this point. If we know this current is known, which is nothing but this current, which is I1, and we are interested in the calculation of this current, I will call it as I2. Is it right? This is I2. We are interested in this calculation of the current. Now I will write the formula for I2 directly. What is the formula for I2? I will use the current division rule. Total current, because current in this branch is known now. Is it right? Total current into impedance of the opposite branch divided by impedance of both branches. I will use that formula. Yes. Any difficulties to someone? Yeah. So here in this case, who is that? Now here in this case, if I am calculating this current I2, how is the current division rule? Total current. Total current is here, which is 4.33 minus J 1.52 is total current into impedance of the opposite branch. Impedance of the opposite branch is minus J5 divided by impedance of both branches is minus J5, this value, plus 3 plus J2. 3 plus J2. This will give the current in the required branch. and then we will take the case 2 and we will verify this particular thing. First, I will work out the calculation of the numerator. If I am working on the calculation of the numerator, start bracket. This is 4.33. This is 4.33 is value. Then minus 1.52 I will close the bracket. Then into start bracket minus 5I will close the bracket is equal to. This is real part. It is minus, this real part is a minus real part is a minus 7.6. This is minus 7.6 is the real part. And how is the imaginary part? Imaginary part is a minus 21.65. This is 21.65 is the numerator. How will be the denominator? I will find out the multiplication, addition of the denominator. How is the addition of the denominator? Start bracket minus 5I, that is J5, that is a plus, start bracket 3 plus 2J, 3 plus 2I will close the bracket. This will give the real part as a 3, real part as 3, and shift up is equal to, and imaginary part is minus J3. Is it right? This is equal to, I will find out this division. This is minus 7.6 is the real part. Then minus 21.65I will close the bracket. Divided by start bracket 3 minus 3I will close the bracket is equal to. This is the real part 2.34. 2.34 is the real part of this calculation, and shift and is equal to, if I am using that, then it is minus J 4.87, 4.87, and this is the value of the current in the first case. Be careful about the calculation. If the calculation error is there, we are not able to match these values. Is it right? This is the calculation of the current flowing through the required branch. Read out the statement. What is the statement here? Calculate the current in 3 plus J2 ohm branch and verify the reciprocity theorem. Now we have calculated the current by using the reduction technique, and now I will consider the case 2. But before that, I will verify the answers from your side and then I will proceed further. Anyone has the calculation? If yes, please raise the hand. I will unmute you and then we will discuss about the calculations. Anyone? Naushad, Saurabh, Ruchira. Yeah, Saurabh.
Yes, sir. Correct.
Correct calculation. Ruchira.
Correct, sir.
Rishikesh.
Sir, correct, sir.
Okay. If we have the correct calculations, then I will proceed towards the step number 2, that is case 2. Is it right? Now I will consider here, this is the case 2. Case 2. What I will do, in the case 2, I will draw the next figure or new figure, and in that case just we will change the positions of V and I, and then we will work out on the calculations. Now look at here. I will draw the same figure. What I will do, this source I will shift on this side, and just this current calculation we will do at this particular point. This here, in this case, this impedance will be the same, which is as it is. This impedance is also same, and here in this case, this impedance is the same. Just I will shift the source here. I will shift the source here, which is 30 and angle 0 degree volt is the source. And in this case, we will plan for the calculation of the current. We will plan for the calculation of the current here, which is this. Which is this. Here, at the same time, I will give some different names. Before that, I will write the values. This is 3 plus J2. This is 3 plus J2 ohm. This is minus J5. This is 2 plus J3. This is 2 plus J3. I will give the names to the current. This current in the second case, I will name this current as I2 dash. क्योंकि यहाँ पे I2 लिया था, तो यहाँ पे I2 dash करूँगा मैं. And but the direction is actual. Its direction should be actual as per this source, because we have the single source, means we can predict the direction. तो इसका current इस तरफ flow होगा. And in this branch, I will give its name of the current, which is I1 dash, which is I1 dash. Is right. And we are interested in the calculation of current, which is I1 dash. How to calculate current? I will use the similar procedure, which is nothing but the reduction technique. If I am using the reduction technique here, how will be the network? I will find out the parallel combination of these two. This next figure will be something like this. Here is one impedance, its value we will calculate. It is a parallel combination of these two. Then here will be the impedance, which is the same as it is, and this will be the another impedance, which is plus. This is 30 at an angle of 0 degree volt is this value, and here is the complete circuit. Is it right? This value is 3 plus J2 ohm is this impedance, and I will name this value as ZP2, that is a parallel combination in the second case, which is the combination of these two. Here, if I am finding that value, how is the formula? Z1 into Z2 divided by Z1 plus Z2, this it is minus J5 into 2 plus J3 is the numerator for this calculation, and denominator will be minus J5 plus 2 plus J3. This is 2 plus J3. I will work out this calculation and we will find out this value of the ZP2. First, I will work out this numerator part. I will work out this numerator part. Is it right? Now, I will use the calculator again to work out this calculation. How are the calculations here? Multiplication in the numerator. This here, in this case, start bracket, this is minus 5i, I will close the bracket, into the second part, which is 2 plus J3. 2 plus 3i, I will close the bracket, is equal to. Real part is the 15. Real part is the 15. This is the 15 is the real part of this calculation. Then shift and is equal to, if I am using, that is minus J10 is the imaginary part of that calculation, divided by denominator. In the denominator, this is minus J5, minus 5i, I will close the bracket, plus start bracket, 2 plus J3, 2 plus 3i, I will close the bracket, is equal to, it is real part of this calculation is the 2. Real part of the calculation is the 2. Shift and is equal to, then its imaginary part is a minus J2 is the imaginary part. Is it right? If I will work on this calculation and if I will write its value, then how is the value of this 15 minus J10? This is 15 minus 10i, I will close the bracket, this value divided by start bracket, 2 minus J2, 2 minus 2i, I will close the bracket, is equal to, its real part is a 6.25. This real part of this calculation is this is 6.25 is the real part of this impedance. Then if I am using this shift and is equal to, then plus J, this is plus J 1.25, and this is the ohm is the real part of this calculation. Is it right? Means this impedance ZP2 is found to be 6.25 plus J 1.25. Now I will use the calculation formula for the total current, which is I2 dash. This current, which is the I2 dash. First we will find out the total current, which is I2 dash. I will use the calculation something like this. I will use this part of the calculation. Here in this case, I will find out this I2 dash. What is the formula for this I2 dash? Which is equal to total voltage divided by total impedance. Total voltage is 3 plus J0 is the total voltage divided by total impedance is 3 plus J2, this value plus this value, and this impedance is 6.25 plus J, it is 1.25. It is 1.25. I will work out this calculation and I will find out this I2 dash. If I am working on this calculation of the I2 dash, how are the calculations? I will discuss here. This calculation. I will work out the denominator. I will keep the numerator as it is. That is 30 plus J0. This is 30 plus J0 is that part divided by denominator. And how is the calculation of the denominator? 3 plus J2. This is start bracket 3 plus 2i. I will close the bracket. Then into plus. It is required is the plus. Here should be the plus because total impedance. That's why it should be plus. Then start bracket 6.25. This is 6.25 plus 6.25 plus j 1.25 means 1.25 I will close the bracket is equal to. Its real part is 9.25. Its real part is 9.25 is the real part. Is it right? Then how is the imaginary part? Shift and is equal to imaginary part is a plus j. It is 3.25. This is 3.25. If we know this part, if we know this, then I will find out this division. If we are able to calculate that particular current, which is equal to, I will use the division, start bracket 30 plus j0 means 30. I will not write j0 for this case. 30 divided by start bracket, that is 9.25. This is 9.25. Then plus 3.25. 3.25 I will close the bracket is equal to, this will give the real part of the calculation, which is 2.88 is the real part of this calculation. Is it right? How is the imaginary part? Shift and is equal to, its imaginary part is a minus j 1.01. This is 1.01 is the part of this calculation. This is the total current which is flowing through this particular circuit in this case. Is it right? If we know this current, how will be the next calculation? I will use the current division rule. Now look at here. This value is I2 dash. This value is I2 dash. I will use the current division rule. How is the current division rule? We are interested in this I1 dash. I will calculate that. This I1 dash is equal to, what is the formula? Total current. Total current in this case means, because in this branch we know the current, that's why no need to bother about this branch. Its current is already known, into impedance of opposite branch, which is this, divided by impedance of both branches. These are the two remaining branches. Means here the equation will be the total current, which is 2.88 minus j 1.01 is the total impedance. Total current into impedance of the opposite branch. Into impedance of the opposite branch is J5. Because in this branch is current, we know the current. In this branch we are interested in the calculation of current. That's why this will be the opposite branch, which is minus J5 divided by impedance of both branches. Impedance of the first branch is minus J5 and impedance of the second branch is 2 plus J3. This is 2 plus J3. Work out this calculation. That will give us the answer. If I am working on the denominator first, impedance total current into impedance of opposite branch divided by impedance of both branches, means here should be the plus. Impedance of both branches, here should be the plus. I will work out on the denominator first. If I am working on the denominator, how will be the case? Just I will discuss here. If I am working on the denominator, it is minus j5, start bracket minus 5i. I will close the bracket plus start bracket 2 plus j3. 2 plus 3i. I will close the bracket is equal to. This is 2 is the real part of this denominator. 2 is the real part of this denominator. Then shift and is equal to, means minus 2i. This minus j2 is this complete part. Is it right? Then how is the numerator? In the numerator, multiplication of these two parts means it is start bracket, then 2.88 minus 1.01 I into start bracket minus 5i. I will close bracket is equal to sign. This is minus 5.05 is the real part, and shift and is equal to this minus j. This is 14.4. This is 14.4 is that particular part. If we know this value, which is equal to, if I am finding this calculation, if I am checking this calculation, everything in this case, otherwise we will work out in this particular fashion. If we are working on this particular calculation, I will find out this calculation. Now, division of these two, start bracket, this is minus 5.05 minus 14.4 I close the bracket divided by start bracket 2 minus 2I close the bracket is equal to. This is 2.33. This is 2.33 is the real part, and shifted is equal to which minus J 4.86. 4.86, and this is the current in the second branch. That is I1 dash. Now we will check or we will verify this particular theorem. Now look at the calculations. For the case 1, the current is found to be 2.34. I will show the values here. I will show the values here in this case. I will show the values here. Look at the current in the case 1. Current in the case 1 is 2.34 minus J 4.87 amperes, and current in the second case is 2.33 minus J 4.86. Here, these are the errors in the calculation due to the fractional part we have discarded. Is it right? This is 4.86 and this is 4.87. This here we have verified this reciprocity theorem. Therefore, we have verified reciprocity theorem. Is it right? Because here, why? Since I2 is equal to I1 dash. Otherwise, its voltage is the same. Actually, we are interested to show the ratio. Means here, if we are finding V divided by I2 this ratio, V divided by I2 this ratio, it should be same as V divided by I1 dash. V divided by I1 dash. This ratio should be same for the verification. If I2 is same, I1 dash is same, V is the same, this V is the same. That's why its ratio will come as the same. That's why we have verified this particular theorem, which is nothing but the reciprocity theorem. I will come back to you. If anyone has difficulty, I will solve that difficulty and then we will proceed further. If anyone has any query, just raise your hand. I will discuss the difficulties.